it's great to get started. Now, before we all spend 5 weeks studying something, it seems like a good idea to see what the goal is. What is Stat 2.1x? Stat 2.1x is the first of 3 courses that make up Stat 2x. And yes, I concede that is not a satisfactory answer, because you are all asking yourselves, well then, what is Stat 2x? Stat 2x is an introduction to statistics. Statistics being the science of drawing conclusions from data. Typically numerical data, lots and lots of it. And so the ultimate goal of Stat 2 is to make you an informed user of all of that numerical information. Now you've seen the introductory video, and so you know that some of the questions that we're going to try and answer are questions like, is chocolate really good for you? How do scientists decide things like that? So that's where we're going to end up in the third of the sequence, and so starting at the end with the third course of Stat 2x, that's where you're going to be able to address questions like, how do scientists figure out whether something's good for you? You know, just the other day I saw online somebody is claiming that vegetarians are more likely to be on time for flights. Now that is fascinating. And I confess, I haven't followed it up and I don't know if it's accurate, but you have to admit it's interesting. By the end of the third course, you will have tools to address questions like that. You will also be able to talk about how polls make accurate predictions when they're based only on a small fraction of voters. So let's examine that for a second. Supposing the person taking the poll just went to his or her 10 best friends and asked how they are going to vote. Well, that might not give such an accurate prediction of the election results, because those 10 best friends might not be a representative sample of the entire voting population. And there's a natural sense that that pollster really ought to have sampled at random. And so the third course in the sequence, which is Stat 2.3x, and it's called Inference, which means drawing conclusions, is about drawing conclusions based on data from random samples. Now, if we're going to understand that, we must understand what randomness means. And that's what the second course in the sequence does. It answers the question, what exactly is a random sample? And while we're about it, we'll look at some more specific things like, well, supposing I've bought a bunch of lottery tickets and they've all lost. Should I buy the next one? So if you look at the specific question that's on your screen, if your last 3 lottery tickets have all lost, then should you buy the next one? Well, that depends on the lottery. Suppose that lottery had only 4 tickets, one of which was the winner, and you've bought 3 tickets and they've all lost, well then absolutely you should buy the next one because it is the winner. But most lotteries have far more than 4 tickets, hundreds of thousands. And then the question becomes much more interesting. If you've lost a few in a row, are you now due for a win? Are you more likely to win? Or should you just stop buying tickets because you're totally out of luck that day? We'll address questions like that and, in general, what we expect to happen just by chance. And that's the second course in the sequence, 2.2x, which is probability, and that is about understanding and quantifying randomness. Now, regardless of whether you've got your data from a random sample, or whether it's from a census asking everybody, or whether it's from asking your 10 or 15 best friends, you are likely to end up with quite a lot of data. Certainly more than you can just glance at. And in order to be able to answer anything interesting, you're going to have to be able to describe that data. And so, finally, what you've been waiting so patiently for, your course, the first course in the sequence, is about making sense of large datasets. It's called Stat 2.1x, Descriptive Statistics, which, it will come as no surprise, means describing and summarizing data. Well, actually, come to think about it, why summarize? Why not just look at all the data? Isn't that going to contain the most information? Well, let's see. Ouch. There's data, and by statistician standards, it's a very modest data set. It's a screen full of scores in the 0 to 100 range. But I'm looking at that, and it's very hard for me to see what those numbers are about, roughly how big they are. They're not making a lot of sense. All they're doing is swimming about on that screen and giving me a headache. I would like a way to say in brief, what are the interesting features of this dataset? I'd like to be able to describe it in a concise manner that's informative. Now, if you are asked to describe a person, you might whip out your phone, take a photograph of that person, and there in the picture you have a lot of information. A picture is a great way to describe something, and indeed, even with data, we are going to start that way with graphical descriptions of the dataset. But sometimes the picture has more information than you need. You might only be interested in whether that person is male or female, in which case all you need is one of the words male or female as appropriate. And so also with data, we will have more drastic numerical summaries. We'll start out simply with one variable like nationality or educational level or income, and then we will build the tools up so that we can handle the relation between two variables. For example, if I know somebody's quiz score, can I say anything about their final exam score? What about educational level and income? There also, we will start out with graphical attempts to answer these questions, and then move on to numerical methods.